Hello everyone, Lance here. Today we are going to have a deeper look at this particle erosion node. Alright, to prepare for today's lesson, I created this particular cliff here. So the base is just a very simple slope like this. Normally we wouldn't be able to do much with this very simple slope, but thanks to the power of the new particle erosion node, we are able to create something like this. Alright, so let's take a closer look at the particle erosion node itself. Now, the first thing you should know about the particle erosion node is this particle size parameter here. So basically we have multiple particle sizes in the simulation, right? And the smallest possible size is actually the size of one square, right? So the smallest possible particle is something like that, all right? And the biggest possible size for the particle is it depends on the landscape itself. It depends on the size of the landscape. Basically, it's the longer side divided by 31. So 1500 divided by 31, it's around 48.4 meters. So the max particle size here can be set to a maximum of 48.4, like so. If you set the number higher than 48.4, then it will make no difference, right? And if you just want to use the maximum possible particle size, then just set this to 0, and this node will automatically calculate the biggest possible particle for the landscape. The next parameter I want to tell you about is the number of passes. Now, the number of passes is actually the levels of details. So basically we have a bunch of big particles, and then the particles will gradually get smaller and smaller to the smallest possible size. And this number of passes indicate the steps towards the smallest possible size, right? Currently it's set to 0, which means automatic, and the node will try to figure out the optimal number of passes for your landscape, depending on the resolution of your landscape. And you can actually override the number of passes using a specific number, for example, in this case, 3. That means you will have 3 levels of details. Let me just erase these. So you have the biggest particles set by this max particle size parameter, and you have one intermediate pass, and you have one pass with the smallest possible particle size. And you can set this to any number you want. However, one thing you should keep in mind is that when you set more passes, you will have more levels of details, and each level of details will run once. And since you have more levels, that also means more simulation, more particles, and more erosion. So here we are running the erosion 3 times using 3 different particle sizes. But if you set this to 6, then the node will run 6 times using 6 different sizes. So of course that will cause more erosion and will consume more time. So anyway, let's try setting this to 3 and bake the landscape once more. And you see, now we only have like 3 particle sizes, and we have one big size, and we have some smaller. Let's see, we have some smaller creases like this, and then we have very small creases, which is the smallest possible size. And if we set this to 1, then this node will always run at the smallest particle size, regardless of this max particle size parameter. So let's bake again and see the effect. So you see, this is the effect of the smallest possible particle size, and the particles are very small, and it's cutting very small creases. And if you set this pass number to 2, then it will run twice, once using the biggest particles and once using the smallest particles. So let's bake once more, and you can see here we have very big creases, and within the big creases we have very small creases, and that's it. So as you can see, the higher this number, the more natural it will look. So let's try setting this to 7. Now it will also increase the time consumption, so let's just bake and wait. Okay, so you see we now have a lot more erosion and also a lot more detail levels. So down here we have some very nice little creases, and up here we have big creases, and within the big creases we have a bunch of intermediate creases, and like this one, this is one intermediate crease, and another one here which is slightly bigger. So yeah, you see, the more passes there are, the more natural it will look, but it will also increase the erosion and the time consumption. So anyway, let's just set this to 0, so we have the sweet spot between time and beauty, right? And back again. There we go. The next thing is the time number. Basically, each pass will run one time, and you can override this using this time number. For example, you can increase this to 2, which means each particle size will run twice. And you can set this to any number you want, but be careful with this number though, because it's gonna increase the simulation time. So let me just set this to 2 and run the particle erosion once more, and there we go. As you can see, we now have significantly more erosion and more details, but also more time consumption. However, it's not doubling the time, because the particle erosion does quite a bit of other computation alongside with the simulation. So this time number will only increase the simulation and not the other computation. So yeah, it's not gonna double the amount of time consumption. Okay, let's set this back to 1. Next, we have the iterations number. So basically, the particles will move a little bit every iteration until it reaches the max iteration, then it will be deleted. Or the particles, once it's find the lowest possible point, it will also be deleted. And the rest iteration is very similar to the max iteration, but during the rest iterations, the particles will not erode the rock and only carry the dirt down the slope. Next, we have the seed. The seed is basically just the randomization of the particles, and we need to bake again in order to get the time back to 1. Okay, now let's set this to 10 and bake once more, and we have a different distribution of particles. And next we have the particle density. I don't recommend changing this parameter way too much, because if you lower this to something less than 1, then you will have less details. But if you increase this to something very high, then the particles are going to cover the entire landscape, and basically it's going to just smooth out everything. And it will also increase the time consumption, because now we have like a lot more particles to deal with. So let's just set this to 2 and bake the landscape once more and see the result. There we go. You see, the erosion is a lot smoother and a lot bigger, but it also increases the time consumption a little bit. Setting this to 1, it will take about around 3.5 seconds. There we go. Finally, we have the erosive power, these 4 parameters. These 2 are for the dirt, and these 2 are for the rock. Now, the max erosive power for the dirt and the rock are meant for the large particles, and the mean erosion for the rock and the dirt are for the small particles. And for the particles in between, it's going to be blending between these numbers. All right. So there is one thing you should keep in mind about the erosive power, because internally, the engine cannot handle the number higher than 1. However, here you can set the number to be something higher than 1, and it will produce a nice result regardless. So you see, it still works, but now we have longer time consumption. This is because I implemented some tricks inside this node to handle a high erosive power. So basically, if any of these 4 numbers is higher than 1, then the engine will automatically increase the time, and it will divide these values by this time, so that each time the erosion run, it will have a power smaller than 1. So basically, if you set the time to 1 and set this to 2 and 2 like that, it's the same as setting this to 1, this to 1, this to 0.25, this one to 0.25, and increase this to 2. They're all the same. So let's see the result. There we go. And let's reduce this to 1, set this to 2, 2.5, 0.5, and bake once more. See, it's exactly the same. And that's it. That's all there is to the particle erosion node. And even though we have fewer parameters to manage, the particle erosion node is much, much more powerful than the previous erosion 2 nodes. And we were able to achieve this kind of result based on this very, very simple slope. So imagine what you can achieve with a higher resolution, with a higher detailed base. For example, let me just put in some more details like this. Now let's bake the erosion once more. Okay, let's see. So you see, we now have a lot more interesting slope. We have this little bump here that wasn't there before, but the erosion is a little too strong, so it kind of got rid of all the existing details and replaced with the creases. So in this case, you might want to decrease the erosion power a bit, like 0.3, this 0.2. Okay, and just leave everything else as default. Now we have something very interesting going on here, and let's render. It looks beautiful. And you can also change the max particle size to something else like 15. And let's see. Now we're talking. And the erosion also runs a little faster with smaller particle size. And let's see. So now we have a lot smaller cuts all over the place. All right, let's check out what the landscape is gonna look like with this kind of displacement. So let's bake again, and you see it's very nice. But let's just set this back to 0, and it looks even nicer. Now we have to render this node so that we have a nice material. So you see we have this nice little trail of water here, and we have very nice flow going on, and the rocks look very natural. Let's increase this back to the default values and bake once more. Look at that. Just look at that. And I think we have a little too much dirt. It's no problem, because we can always go here and manipulate this dirt map to get a nicer distribution between dirt and rock. So just drop in a map value and do this. All right. Now we have a nice looking dirt map, and now it's beautiful. And for the sake of demonstration, I'm going to increase the resolution to 1024. Okay. And this one took around 3.5 seconds. And let's bake once more to see how long it will take. And it's finished, and it took 110 seconds. So it's almost 2 minutes. So the time consumption increased by 31 times. So yeah, as you can see, the time consumption scale up quite quickly with the higher resolution. The maximum resolution that I tried on my computer was 4K, and it took the default values around 2 hours to run. So I think an 8K landscape will take around 16 hours. So yeah, be careful when you increase the resolution. Anyway, let's have a look at the render. As you can see, it is absolutely beautiful. Look at these water channels. Look at these. Beautiful. This was not possible before using Erosion 2 node, but now it's possible thanks to the new particle erosion node. So again, this particle erosion node is a part of the latest free update for World Blender. And you can now download the latest version of World Blender from wherever you bought it, and you will have this nice particle erosion to play with. Okay, in the future, I'm going to show you how to use World Blender to create a wide variety of different types of landscapes. Okay, that's it for today. Thanks for watching. I'll see you next time.